Have you ever wondered what it takes to power the AI that fills your social media feeds? The answer is getting more and more complex, and it's not just about cramming more GPUs into a data center. A recent announcement from a major chip maker and a leading social platform has sent a clear signal to the entire tech industry. The era of generic hardware for cutting-edge AI is over. On February 24, 2026, these two giants deepened their partnership, and the message was unmistakable. They were moving beyond off-the-shelf solutions to build AI systems specifically designed for the platform's unique needs. This isn't just a minor upgrade. It's a fundamental shift in how we think about building the future of artificial intelligence. The key phrase that really jumps out from their announcement is gigawatt-scale. Let that sink in for a moment. Gigawatts. That's the kind of power consumption we associate with entire cities, not just a bunch of computers. This tells us that training and running the most advanced AI models is now being treated like massive industrial infrastructure. It's no longer just about the cleverest algorithm or the raw power of a single chip. Now the game is all about total system efficiency. We're talking about power delivery, advanced cooling systems, global supply chain management, and how all these pieces fit together. It's a holistic, industrial-level problem, so what does this actually mean in technical terms? Well, it's a two-part story. First, we have customization. By creating custom-designed accelerator chips, the social platform can perfectly optimize for its specific mix of tasks. Think about everything that happens when you open their app. You've got recommendation engines figuring out what you want to see, ranking systems deciding the order of posts, complex ad-serving platforms, and increasingly, generative AI for creating images, videos, and text. There are also powerful internal tools that their own developers use. A generic GPU is a jack of all trades, but a custom chip can be a master of the specific ones that matter most to the platform, making everything faster and more efficient. The second part of the story is roadmap alignment. This partnership isn't a one-off deal. It suggests a deep, ongoing collaboration. The social platform's AI researchers can now influence the chipmaker's hardware design process much earlier. They can say, hey, our next generation models are going to need this specific type of memory bandwidth. Or, we're hitting a bottleneck with this kind of data transfer. This co-design process allows the chipmaker to build features directly into the silicon that solve real-world problems before they even become critical bottlenecks. The end goal is to dramatically improve performance per watt, which is the holy grail of data center efficiency. It also helps to stabilize their supply chain and make it easier to plan for building out these enormous AI clusters. Now let's zoom out and look at the bigger picture, the market impact. What we're seeing is a consolidation of the AI stack. A handful of massive tech companies are forming tight, exclusive alliances with chip designers. If a platform can secure a reliable supply of custom-built accelerators and finely tuned systems, they gain a massive competitive advantage. They can train their AI models faster, they can serve those models to billions of users more cheaply, and they can innovate and release new features more quickly than anyone else. This creates a powerful feedback loop that can leave competitors in the dust. For everyone else in the AI space, the message is pretty blunt. Being competitive in AI is no longer just about writing clever code. It is about securing your access to a massive amount of computing power and having the engineering talent to design these incredibly complex systems from the ground up. The playing field is tilting in favor of those with the deepest pockets and the strongest hardware partnerships. This trend could create a new kind of moat in the tech industry, where access to specialized compute becomes the ultimate barrier to entry for startups and smaller companies trying to compete with the giants. So what should we be watching for over the next year or two? First and foremost, delivery timelines. It's one thing to announce a partnership. It's another to actually ship hardware at the scale we're talking about. Any delays could have huge ripple effects. Second, we need to keep an eye on the software tools. Custom hardware is useless without a mature and easy-to-use software ecosystem that allows developers to take full advantage of it. The success of this venture will heavily depend on how good the software is. Finally, and most importantly, we'll be looking for the proof in the pudding, measurable gains. Will these custom platforms actually deliver significant improvements in key metrics? We're talking about throughput, which is how much work can be done in a given amount of time. Latency, the delay before a request is processed. And